All right, please give a hand for Alex McLean, live coding Konnakol.
Thanks very much. Thanks to all the organisers. It's a real pleasure to be here. I think I instigated the first farm performance evening 10 years ago. So, yeah, thanks to the organisers and for all the organisers along the way, keeping the tradition alive, and for all the functional programming people supporting it with your ears, listening to these strange noises of an evening. So I'm going to be not really live coding Konnakol, but doing some work inspired by Konnakol, which is a South Indian practice. It's going to be improvised. I'm not sure exactly what's going to happen, but working with some South Indian tala structures. I need to have my glasses on for this. So let's start with this one. So this is a 7-step sequence. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So this is called the Mishra Chapu Tala. So we'll leave that underneath, marking that. And let's put some drums on top. Let's try. So that sounds good. So let's try doing some like grouping with this. So let's try expand by a factor of 1.5, keeping it at 7 steps. So you can kind of see, if you times 7 by 1.5, you get 10.5, I think. And if you times that by 2, you get 21, which is divisible by 7. So 3 repetitions of this is 1.5 repetitions. Or 2 of them. So it fits the tala. But let's make it a bit more interesting. Let's make it fit 2 repetitions by having 10.5 steps, followed by 3.5 by dividing that by half, which adds up to 14, so this should work. Yeah. You can see that fits nicely. Let's have a look at what it looks like. But it's nice to do things in 3, so let's add one more repetition in the middle, just at the normal speed. So now we should get 3 repetitions of the tala and of the rhythm. And then we can do the same but backwards, so go half, 1, and then 1.5 times, and it should all fit in nicely. But I decided recently to only ask my computer to run algorithms that I'm prepared to perform myself. I think this maybe connects with something from the keynote about having disembodied algorithms that you can't actually hear, they're inaudible. So to try and keep it embodied, I'm going to try and do this myself, so fingers crossed. ta, ki, ta, ta, ka, de, mi, ta. Yeah, okay, I think this is right. Let me try. So, ta, ki, ta, ka, de, mi, 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 ta. Oh, yeah. Thank you. Right, so let me kind of improvise with this a bit more, see what happens. Right, so thank you. I'll try one more. So this one will be based on a 3-step Thaler, like this. So the previous one was the Mishra Chapu Thaler. This one is the Rapaka Thaler, which goes clap, clap, wave. So let's start with the number 8, like this, 7, fit that to scale. So that isn't fitting too well just yet. So let's try a Yati structure. So to do that, I'm going to remove a step from the sequence every repetition. So if I remove one step each time, then that should create a triangular number. So 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1 is 36, I think, which is divisible by a whole lot of numbers, including 12. So if I've got this 3-step Thaler with 4 beats per step, then it's hopefully going to work. Let's see. Yeah, so that fitted. Maybe you saw that. So again, I'll try and do this myself. Let's see, 1, 2, 3. You can try clapping along if you like. Might help. Might make it worse. So it goes 1, 2, and then the back of your hands. So you'll start feeling those 12s, maybe. Tadi gina tam tadi gina tam tadi gina tam tadi gina tam takadina taki to takatata taki to takadimi tadi gina tam tadin gina tam tadin gina tam tadin gina tam tad. So maybe you kind of felt the syncopations happen. So you have this regular rhythm underneath, which is kind of setting the pace. And then having these rhythms move around on top as they shrink, generating these syncopations. So just something as simple as removing a step kind of generates all these rhythms and physical sense. So again, let me play this a bit more. That's it, thanks.